Okay, good afternoon. Welcome to
FamilyMath1031.
So I've asked you to, just like your brother, to pick a chapter in this book, in Burkard Polsters' book, that you thought was interesting, and we're going to talk about it. So what did you find?
So this is about Archimedes' theorem, which is...
Can you hold the book, please?
Kind of two different things.
Okay.
One is proving that the sphere is 2/3 of the volume of the smallest cylinder that can contain the sphere.
Okay.
There's kind of a neat way over here of how you can derive that without needing to know the 4/3 pi r cubed, which is actually kind of where that formula comes from.
Okay, yeah, nice.
And then there's another part of it where you can project every point of the sphere, except for the north and south pole, onto the cylinder, and then unwrap the cylinder and make a projection of the sphere that's two-dimensional, which is useful for a different type of map that preserves the areas on the globe, which is what's down here.
It preserves areas.
Yeah, this map here is different than a normal map because it preserves the areas and not the shapes of the countries. It preserves, all the countries have the areas that they would if they were on a globe, but the shapes are distorted.
Okay, so what do you want to talk about first?
We can talk about the derivation.
Okay, cool. Do you think you know it, or do you need to refer to the book?
I need to look at the book.
You need to look at the book?
Yeah.
Okay.
So they...
Oh, let me zoom out a little bit. I forgot to do that in your brother's. But yeah, okay.
So I'm not entirely sure how they do it here, but they have a...
Okay. That's
so
all right. Do your best.
They start with a cylinder and a cone.
Huh?
And they sort of put the cone... I'm going to try to draw that, but... They put the cone sort of inside the cylinder like this. And then they make this second circle here. And then they can somehow make the argument that the cylinder minus the cone is equal to half a sphere.
Okay.
Which I don't quite understand what this is for. But they use something called Caldevery's principle, which I think is where you chop it up into rectangles and then you chop it up into smaller and smaller rectangles, and then chop it up into infinite rectangles and try to preserve congruence that way.
Okay, yeah. So why don't we do this? Just looking at the picture, my guess is I have not read this chapter, but my guess is what they're doing is showing that the area of this, what should we call it, a donut, sort of a two-dimensional donut shape.
Yeah. That
white circle is the same area as this circle.
Okay, so then they preserve it. They do it layer by layer. So they have like a bunch of little. They have a bunch of little cylinders. Here are kind of rings. And then these map to little cylinders in the half sphere. Well,
they probably have the same area. That's just my guess. So let's take a look at that because
it says there
on the bottom. So we're on the bottom here.
So
it's going to be
that's the top for us.
That's going to be the top of the sphere.
So here, because it's just at least like right before the bottom, it's just a single. Very small piece of area.
Okay, so why don't we talk about, so this would be a height of r of the sphere, right?
Yeah, and then it's a radius of r.
A radius of r. And then let's go up h from the bottom. And then we'll find the area of that kind of donut. And then we'll find the area of the same circle slice of the sphere. And hopefully they'll be the same.
All right.
Otherwise, I will have led you down the wrong path. But I hope they're the same. All right, so how would you approach this problem?
Well, you need to find the radius of the outer circle, and find the area of the outer circle minus the area of this inner circle. So the outer circle is always going to be pi r squared. Because that just stays the same.
Mm-hmm.
And then the inner circle, well, what can we say? So we have a height of h. I guess we have a triangle that we can look at.
Yeah, you got plenty of room like over here.
Yeah, so we have a triangle. So one side is h, and then one side is going to be, I'm just going to call it this x of our small circle.
Yep.
And then we have another unknown.
Yep, have that.
I'm not sure if that's helpful or not.
I would
So,
say maybe fill in
yeah.
some other parts that you might.
I think we want to draw a bit of a different triangle. So this is R, this is R, this is H, this is X,
Okay.
and then this is R root 2.
All right.
And then we know these triangles are similar.
Okay.
So this is H, or R minus H. So we can say then x over R equals R minus H. Well then, yeah, x is R minus H.
All right.
So then for our formula we have pi r squared minus R minus H squared. I'm just going to take the pi out. So it's pi times this.
Okay.
So we need to remember this, and then we need to do this for the half sphere now.
Okay. Great. Let's move to the second video.